And the last but not the least, presenter Artem Kachur with topic challenges toward VR technology. Are you ready?
Hello, just 1 second.
Please try to do it in 10 minutes, if it's possible.
Yeah, sure, I will. Um, 1 second. Do you see it?
Yes, but we see in not presentation mode, but in slide mode.
Okay, what if we change the window?
Now it's okay. Now it's okay.
Oh, sorry.
It was okay.
Should be okay now.
Yeah, yeah. Now it's okay. You can
The,
start, please. Thank
the
you.
slides change?
Yeah, everything is okay.
Okay, thanks. So, dear colleagues, hello everyone. I'm happy to introduce you the presentation for a research dedicated to challenges towards VR technology and VR architecture optimization. The agenda will be the following. We will consist of 4 parts. The first one is introduction with a general review, key aspects, motivation, and setting the goals. The second one is a background research with a case study, and we'll present a VR optimization roadmap. We will review the state of the art in this field of study and review existing approaches. In the third part, we will work in problem analysis, define optimization challenges, and find bottlenecks in existing solutions. And in the fourth part, we'll consider results with a comparative analysis of existing approaches. We'll define the need for a comprehensive solution, make some conclusions, and define the space for further research. So the paper that we're presenting reviews the crucial need for VR hardware and software co-optimization, emphasizing a holistic strategy balancing latency, power, stability, user experience, and efficiency. We advocate for collaboration across computer architecture, HCI, software engineering, and cognitive science to foster the growth and adoption of VR systems. Okay. Um, let us define the key aspects of VR architecture optimization. So it tailors system components for better performance and efficiency and user immersion. This paper delves into the challenges and solutions of refining hardware to meet VR application demands and ensure smooth user experiences. The motivation of this paper is that VR architecture optimization seeks to boost performance, efficiency, and cost effectiveness. While it uses diverse methods from algorithm design to system assessment, the multifaceted challenges arise from the dynamic VR applications and the intertwined relationship between hardware and software. Let us define the key aspects of VR architecture optimization. The first one is trade-off decision, because hardware optimization requires balancing factors such as power, efficiency, and cost. There are some techniques like DVFS and machine learning frameworks described in papers 14 and 15 of the paper. The second one is hardware complexity, because hardware tricks account for component links. There are some approaches such as SSCN technology for virtual and augmented reality challenges, and for instance, an FPGA strategy like zero removing. The next aspect is technology limitation, because everything in this field of study is based on transistors, and transistors do get smaller. They're like literally microscopic. They face some issues like signal leakage and overheating. So factors like HCI and self-heating impacts should be considered related to FETs. And the factor that we're going to pay between hardware and software. On the one hand, hardware needs to run software effectively. On the other hand, software should effectively utilize the hardware capabilities. The next aspect is future proofing. Balancing future requirements with current needs is a complex task, and one of the approaches to receive it is refurbishment. Uh, Also, an important aspect is testing and validation, because ensuring functionality involves extensive testing, including techniques like hardware in the loop. And the economic aspects of this is cost effectiveness because the benefits of hardware optimization should be measured against production expenses. Genetic algorithms are used to minimize cost in distribution systems. So the goal is that given the intricate relationship between VR hardware and software and the challenges posed by technological trade-offs and evolving VR applications, there's an urgent need for an interdisciplinary scientific research to develop holistic optimization solutions that will not only improve VR system performance but also ensure their longevity, adaptability, and cost effectiveness. Let us review the roadmap of VR architecture optimization. So we can divide it into 9 aspects. The first one is, firstly, we should define optimization objectives, which are performance, energy efficiency, and cost effectiveness. The second part is trade-off decisions, which include application requirements, budget constraints, system constraints, and optimization techniques. The third part is addressing complexity, which includes hardware interdependencies and technological challenges. The fourth aspect is overcoming technology limitations, which includes aspects related to nanoscale challenges in transistors. The fifth aspect is hardware and software co-optimization related to efficient execution and leveraging hardware, and this is what we mostly work on. The sixth part is future-proofing hardware, where we should define the anticipated needs, balance specificity and generalities inside this aspect, and consider refurbishment to extend the lifespan of electronics. The seventh part is testing and validation, which includes prototyping, hardware in the loop testing, and iterative testing. The eighth one is ensuring cost effectiveness, which is an economic aspects and includes budgeting and cost reduction techniques. And in the long run, we should achieve review and analysis part with research integration and problem mapping. In this article, we'll review the state of the art in VR hardware and software co-optimization and emphasize the importance of it in VR. So balancing general purpose hardware with specialized software is challenging, but collaboration between developers can streamline performance and address its bottlenecks. So the first approach um, is called visual inertial odometry. So the article number 19, as it's referred to in the paper, discusses the importance of VIO in determining position and movement trajectory for various augmented and virtual reality applications. And the functional scheme of the system and chip interconnection can be seen on this slide. Another study details the mobile system and chip and detection using the codec avatar model. So there is also a system and chip made with a 7 nanometer technical process, and it features a neural network accelerator. Also, we can see the functional scheme in the right part of this slide. Uh, in paper number 38, the Dune VR platform is introduced, offering enhanced interaction and integration with top CAD engines. So it's related to a software architecture designed for complexity and to balance performance with cost effectiveness. So the priority of this platform is to improve the interaction of CAD engines and their compatibility. The next paper reviews an innovative VR video processing solution, uh, which results in significant energy savings. But this is the only aspect that it reviews. So, unfortunately, other crucial aspects that we mentioned before aren't considered in this paper. However, the functional scheme um, of the video processing solution can be seen on the right. It's a software solution mostly. The next study presents a case study for real-time energy-efficient pulse estimation. So some advancements have been made in energy efficiency and performance for hand-code estimation using dynamic quantization and FPGA architecture. Still, the lack of focus on hardware stability and development ease may limit its widespread and applicability in various settings. The next paper addresses programming challenges and high performance, since development is also an important aspect of creating such systems. So it emphasizes development convenience via structured parallel programming. However, it still may neglect some key aspects like latency, power consumption, and hardware stability. It's only focusing on development. The next article tackles the challenge of providing a high-quality VR experience with 360 video streaming due to latency and bandwidth constraints, primarily in 5G networks. So it proposes a solution using tile-based 360 streaming and mobile edge computing, which is so known as MEC caching, to predict and deliver the necessary tiles for the device's field of view. The next paper aims to improve information access and interaction in VR system, reduce user cognitive load, and optimize VR design efficiency. It introduced a method named QFD-CNN, which assesses multi-channel VR information characteristics, creates a VR scenario resource correlation matrix, and deploys an evaluate an AHP-QFD to create an evaluation matrix to rank VR resource traits. So this is rather about the cognitive optimization of how the cognitive information is formed. Uh, One more paper presents research on optimization of wireless VR transmission challenges like content volume, quality of service demands, and narrow cellular bandwidth, also primarily over 5G networks. Uh, so the paper itself uh, represents how nearby VR devices create multicasting clusters and clusterize the calculations using D2D modes and utilizing regular end user uplink resources. So the challenges from the aforementioned papers can be delineated as following: latency, power consumption, hardware stability, and consumer usability, portability, and software development. Here we can see a comparative analysis of those challenges and how they're solved or not solved in the papers that we've analyzed. As we can see, some of papers address more of those challenges, some of them address less, some of them are combined, but there is no work which creates like an integral or like a comprehensive solutions to all of those problems. That being said, based on the identified patterns and insights from the reviewed literature, future research in VR hardware and software co-optimization should emphasize integrated solutions that holistically address challenges in the field. This entails a comprehensive optimization strategy, balancing factors crucial for seamless VR system operation and adoption. This objective involves optimizing all these factors, striking a balance between real-time responsiveness and energy efficiency, which requires careful consideration of hardware and computational capabilities. Enhancing user experience involves multiple facets like ergonomic design, intuitive interfaces, and seamless interaction. So achieving portability extends beyond platform compatibility to adaptive mechanism for various computational environments. Streamlining development is indicated by development efficiency necessitates advanced software tools for creating, testing, and deploying VR application across heterogeneous hardware. So future research, in our opinion, should focus on the balanced methods and approaches encompassing latency, power consumption, hardware stability, user experience, portability, and development efficiency, all those factors that we've mentioned before. This integrated strategy, driven by interdisciplinary collaboration, holds promise for transformative advancements in widespread VR adoption and evolution. Once again, we should find a comprehensive integral solution to balance the factors: latency, power usage, and so on. While VR presents groundbreaking opportunities, it's a demanding challenge to optimize it for widespread and comprehensive usage. So this involves enhancing realism, streamlining data management, latency reducement, and improving tactile interaction. Uh, Such challenges highlight the need for research that combines all the technology, user experience, and industry-specific design. Future research also should prioritize holistic solutions that span across the data capture to user experience continuum, emphasizing both technological breakthroughs and user-centric design to harness VR's full potential across various domains. This integrated strategy, driven by interdisciplinary collaboration, holds promise for transformative advancements in widespread VR adoption and evolution. Thanks for your attention. In case you have any questions, please feel free to ask.
Thank you, Tim. Unfortunately, we have no time for questions, but thank you for your fruitful work and very interesting presentation.